A class, this is lesson 6.3. The objective here is to determine whether quadrilateral is a parallelogram. So go ahead and do the review quickly. Check back for the answers. All right, there's a bunch of theorems we're going to use here. Here they are. They all deal with how you can prove a quadrilateral is a parallelogram. In 6.8, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. 6.9, if an angle of a quadrilateral is supplementary to both sides of its consecutive angles. If both pairs of opposite angles of a quadrilateral are congruent, if the diagonals of a quadrilateral bisect each other, if one pair of opposite sides of a quadrilateral is both congruent and parallel, in any of those cases you can prove that the quadrilateral is a parallelogram. So go ahead and look back at those theorems and pause here and fill in what you think 11 through 16 should be using those theorems. All right, so we're going to use those properties to work with parallelograms. So for what value of x must RSTU be a parallelogram? Well, if it's a parallelogram, if the opposite sides are congruent, then it's a parallelogram. So we can get two equations from that. 5y is equal to x plus 8. And 4y minus 3 is equal to 2y plus 5. From the second equation, this one, we can solve for y. So I'm just going to subtract 2y from both sides. So I get 2y minus 3 is equal to 5. Add 3 to both sides, and we get 2y equals 8. Divide both sides by 2, and we get y equals 4. And then using the other equation, 5y equals x plus 8, we can substitute the value we just found for y, and we get 20 is equal to x plus 8. Subtract 8 from both sides, and we see that x is equal to 12. And just to check that, you might want to substitute 12 in for x. So 12 plus 8 here. And that gets us 20. And then substitute 4 for y. 4 times 4 minus 3, and 16 minus 3 is 13. 2 times 4 plus 5 is also 13. And 5 times 4 is equal to 20. So we can see that opposite sides are congruent. Go ahead and you try this problem. Check back for the answers. All right, problem 2, decide whether a quadrilateral is a parallelogram. Can you prove the quadrilateral is a parallelogram based on the given information? What theorem can you use? So we're given that AE and CE are equal, and they're both 14. And we're also given that GB is equal to 2DE. Prove that ABCD is a parallelogram. Well, if we're given that AE is equal to CE, and that is enough to say that BD bisects AC by the definition of a bisector. And we're also given that DB is equal to 2 times DE. And that means, we also know that EB is equal to EB plus DE. And that's by the segment addition postulate. Then putting those two together using the transitive property, we get that 2 times EB is equal to EB plus DE. Again, that's the transitive property of equality. And now, we can say that DE is equal to EB just by subtracting DE from both sides. So the subtraction property of equality. And now that we know that AC bisects BD by definition of a bisector. And now we know that we have the diagonals bisecting each other, both of them. We can say that ABCD is a parallelogram. And that's from the theorem that says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay. Here we can try another proof, given that the measure of angle y equals 49, and the measure of angle z equals 131, and the measure of angle w equals 49, prove that WXYZ is a parallelogram. All right, so we're given that the measure of angle y is 49, that's this one. And we're given the measure of angle z is 131. And we're given the measure of angle w equals 49. And if you look closely here, you'll notice that those two numbers add up to 180. And those two numbers add up to 180. And so we can use the idea that if one angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So I'm just going to go through showing that now, but you got the general idea. I'm going to pause here, and then you can check back for the map. So I wrote down my statements, and I'll just fill in the reasons. These are given. This is, we're just going to call that addition. And measure of angle y plus measure of angle z equals 180, measure of angle z equals measure of angle w equals 180. And that is by substitution. And we get that angle y and angle z are supplementary, and angle w and angle z are supplementary, and that's just the definition of supplementary angle. And because of all that, we get wxyz as a parallelogram, and that's because if one angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. All right, go ahead and try problem 2. Check back for the answer. So no, you cannot prove that DEFG is a parallelogram because it could be an isosceles trapezoid according to the information we're getting. This line could go like that. You'd still have congruent opposite sides there. And so angle D and angle G are not necessarily congruent. All right, problem 3. Table 3 can be adjusted up or down by raising or lowering the table on its hinged legs as shown. Will the table always remain parallel to the surface? And we're going to say yes, and the reason is that both pairs of opposite sides are congruent. So the quadrilateral formed is a parallelogram, and by definition of a parallelogram, there are two pairs of parallel lines. All right, problem 3. New. 90.
Short share certainly doesn't exclude yourself.
All right, the lesson check. How is theorem 611 in this lesson different from 6.6? Actually, the two theorems are the converse of each other. So we would use theorem 6.6 if we're given a quadrilateral, and we're going to try and prove something about the quadrilateral, or given a parallelogram. And we would use 6.11 if we are proving it's a quad, proving it's a parallelogram. All right, that's it. See you tomorrow.